Hello again, this is Mark Summers from Summers Technical Services. We're going to talk today about our stress strain diagram and review how we extract some of our important material properties, mechanical properties from the tensile test, and also talk about how to determine yield points for ductile materials that don't exhibit a true yield point like the ones we showed in class. So let's get started. So here's the spreadsheet that you'll be using to do our tensile test, data input and calculations. But I want to move over to this stress strain plot over here and review what we talked about in class the other day. And so let's identify some of our important parameters we're going to pull from this chart. So we're plotting stress versus strain, and sigmas we'll use for stress, strain we'll use epsilon, and we're using inches and pounds here, so the stress will be in psi and the strain will be inches per inch, unitless. And so the parameters we're interested in are Young's modulus, the yield stress, and the ultimate stress. And so let's tackle the easy one first. The ultimate stress is easy because all we need to do is read off the maximum stress on the stress strain curve. And so looking at my chart here, looks like this point right here is the maximum stress. So if I walk over to the y-axis here, this is 20,000, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're 1,000 psi increments, so the yield point we can write down is 29,000 psi. All right, now let's talk about Young's modulus. So what's Young's modulus? Well, Young's modulus is the slope of this straight line portion of the stress strain curve, so we want the slope of that line right there. So how do we do that? Well, we just need to find, it goes through 0, 0 by definition. And we need to find another point. And a convenient point might be this point right here. This is still in a straight line portion. So I want to know the slope of that line between those 2 points. And so I can just say Young's modulus equals stress over strain. And the rise is 20,000 psi. And the run is 0.002 inches per inch here. Let's go straight down here and go over to here. So any of these points along that line we could have used, but I chose one that crossed the intersection there on the grid lines. And so if I get out my calculator, I can determine that Young's modulus is 10 million psi, which tells me it's probably aluminum. Put a question mark. But aluminum is about a 10 million psi modulus of elasticity, or Young's modulus. And so this is potentially aluminum material from this test data we've gotten. Another property that we didn't talk about, I didn't write down here, but we also might want to know percent elongation. And you'll remember that percent elongation is just strain at failure, and so failure is right here. And so again, if I walk down to the x-axis, this is 8, 10, 12, 11, 12, 13, 14, 15.015 strain, and it's percent elongation. So I want to move the decimal place over 2 places, and so the percent elongation in this case is 1.5%. So that's the percent elongation, and based on our rule about 5% breakpoint, this must be a ductile material. So maybe aluminum is not what this is, because we know that aluminum is ductile, This is not a ductile material based on the percent elongation. So I don't know what this material is. All right, now let's calculate yield point. And as we talked in class, the yield point is defined as the point where you get increased strain without increased stress. And that's where we saw that little wiggle on the stress strain curve. This doesn't have a spot that defines that point, so we're going to use what's called the 0.2% offset rule. So here's how that works. So what you do is you start off with 0.2% elongation, and so 0.2% implies 0.002 strain. And so we're going to start right here. So where is it here? So 0.2% offset, we're going to convert that to strain. So we move the decimal place over to the left 2 places. So that's where we get 0.002 strain. And then all we do is we draw a line parallel to the original data curve. I can carefully draw a parallel line here. I'll eventually draw one here. Straight line. There we go. And I need to get my straight edge out, and I need to make sure it's parallel. And so that makes sense. Let's go over 1, 2, 3, 4. So that looks like a parallel line. So I'm drawing a line, starts off at 0.002. It's parallel to this original line here. That's the data line. So I draw that parallel line, and then I just come over here and pick off the intersection, and I walk over to the y-axis and just read the value off, which looks like 27,000, 28, 29, 30. Yep. So that's the yield point. So the yield strength of this material is 27,000 psi. So if it's got a well-defined yield point, you just read it off the chart. If it doesn't have a well-defined yield point, then you can use this 0.2% offset rule to calculate a yield point for your material. So that'll complete this video. We'll do a next video. We'll talk about how we take our data from the homework assignment and compute these values based on the data you're given. So thanks for watching, and we'll see you in the next video.